Today we're doing section 1.8 and we're going to talk about the inverse function. So basically to determine if a function is the inverse of each other, if I find f of g of x and I get x, and then I find g of f of x and I again get x, then you can determine that they are the inverse of one another. The notation that we use for inverse is this little -1, so the way we pronounce this is the inverse function of f. So for our first example, we're determining if these two functions are the inverse of one another. So to do that, we're going to find f of g of x first, and this is something we did yesterday. And that's where I'm going to take the g function and input it into the f function. So I'm inputting this g function into the f function. And if I multiply this out, this is like a 3 over 1. Those 3's are going to cancel, and I'm left with x minus 2 plus 2, so I get x. So I'm good to go halfway. Now I need to find g of f of x. Okay, so now I'm going to plug the f function into the g. So I'm plugging 3x plus 2 in that top for x. So I have those 2's are going to cancel, and I'll be left with 3x over 3, which is x. So because I got x in 2 times, I can determine that they are the inverse of one another. So the next thing we're going to discuss is if you have one function, how do you find its inverse? So it's a few-step process. So the step 1 is to replace f of x with y. Step 2 is to switch x and y. Step 3 is to solve for y. Step 4 is to replace y with the inverse of f. So we're going to go ahead and do a couple examples where we're finding the inverse if a function is given. So here, first step, I would change f of x to say y. And now I'm going to switch the x and y spots. So this y and this x are going to flip-flop spots. And now the goal is to solve for y and isolate y. So I'd have to add 5 over. So now I have x plus 5 equals 7y. And then we would divide both sides by 7. So my inverse function of f is x plus 5 divided by 7. So this is an example of an easy one. We're going to do a couple more difficult ones. So here we have f of x equals x cubed plus 1. So first step, I'll change y equals x cubed plus 1. I'm going to switch x and y. Now we start solving for y, so I subtract 1 from both sides. I have x minus 1 equals y cubed. To solve for y, I need to take the cube root. And now I've gotten y by itself, so I can change it back. So the inverse of f is equal to the cube root of x minus 1. And again, if I were to evaluate these functions at each other, I would get x. So one more example for today. So here we have 5 over x plus 4. So I have y equals 5 over x plus 4. So switch x and y. Now I need to solve for y, so I subtract 4 from both sides. So x minus 4 equals 5 over y. And then to solve for y, I'm going to times both sides by y. Now, I don't want to distribute the y in because the goal is to isolate y, so I don't want to put y in 2 different spots. So I'm going to keep it like this. And now to solve for y, I'm going to divide both sides by this x minus 4. So my inverse of f is equal to 5 over x minus 4. So that's all for today on inverse functions. We'll pick up with this tomorrow.